For years, one type of AI architecture has been the undisputed king. But what if its entire reign is built on a hidden flaw? And what if the next giant leap for AI isn't about creating something totally new, but about cleverly combining the old with the new? So, I want you to keep this question in your head as we go through this. What if the very foundation of modern AI, the thing that powers almost everything we use, has a fundamental weakness? A weakness that a new breed of hybrid model is specifically designed to fix.
Okay, so to really get where we're going, we've got to talk about where we are right now. And right now, we are living deep in the era of the transformer.
Back in 2017, this thing called the transformer model just exploded onto the scene. It completely took over, leaving older models like recurrent neural networks or RNNs in the dust. They became the absolute gold standard for pretty much every language model out there, mainly because their ability to process huge chunks of information all at once made them seem, well, unstoppable.
But here's the crazy part. It turns out that both the new king, the transformer, and the old king it replaced, the RNN, had these really critical weaknesses. And what's so fascinating is that their flaws are almost perfect mirror images of each other.
Think about it like this. A transformer is like a brilliant researcher. You can hand it an entire library, thousands of books, and it can instantly find one specific fact on, say, page 500 of book 27. An RNN, on the other hand, is more like a great storyteller. It follows a plot meticulously, step by step by step, always remembering what just happened and how that affects what happens next. The researcher is a genius at recall. The storyteller is a master of sequence.
And that right there, that's the transformer's big blind spot, state tracking. It's like if you're trying to follow one of those shell games, where the ball is under one of three cups, a transformer kind of gets lost. Because it tries to see everything at once, it has a really hard time following a series of changes where the order is the most important thing.
Now, the RNN, it has the exact opposite problem. Its memory is like a one-way street, and it's not infinitely long. So while it's fantastic at following that story plot, it can't just jump back to that one specific fact on page 500. And that's a huge problem when you need to pull very specific details from a ton of text. So what do? You have these two powerful tools, and one's weakness is the other's strength. Well, it's kind of obvious, right? You smash them together. And that's the whole idea behind this new wave of hybrid AI models.
And that's exactly what researchers at the Allen Institute for AI did with a model they're calling OlmoHybrid. The architecture is honestly surprisingly straightforward. They just mix the two types of layers together, combining these powerful modern RNN layers with the tried and true attention layers from a transformer.
So here's what the recipe looks like for their 7 billion parameter model. It's a 3-to-1 ratio. For every one transformer-style attention layer, they slot in 3 advanced RNN layers. They're literally weaving our storyteller and our researcher together right into the fabric of the AI. And what you get out of this isn't just, a model that's okay at two things. No, by combining them, you actually unlock a brand new capability that neither one could do on its own. This is a classic case of the whole being way stronger than the sum of its parts. To really get why this is such a big deal, we need to touch on this idea called expressive power. Basically, it's the range of problems an AI is even capable of solving in theory. You can think of it as the set of tools in the model's toolbox. Okay, so this is the absolute key takeaway. Transformers have the recall tool. Modern RNNs have the state tracking tool. But there's this new class of problem called state-based recall, and to solve it, you need both tools. Only a hybrid model has both in its toolbox. So let's walk through how this works. Imagine you give it some code to analyze. First, the RNN layers, that's our storyteller, carefully track how the variables change, line by line, to figure out their final value. Then, the attention layers, our researcher, take that final value and use it to look up the correct information from way back at the beginning. You see, neither one could have done that on its own, but together, they absolutely nail it. All right, so that's the theory. It sounds great on paper, right? It's elegant, it makes perfect sense, but does it actually work in the real world? Well, the OlmoHybrid paper puts this to the test, and the results are pretty fascinating. First thing they looked at was efficiency. This chart basically shows a race to a specific accuracy score. And as you can see, the hybrid model hits that finish line way faster. It's just a smarter, more efficient learner from the get-go. So how much more efficient are we talking? A whopping 49% fewer training tokens? That's almost half. In the world of giant AI models where training costs millions, that is an absolutely massive deal. We're talking potentially half the cost, half the time. Okay, so it learns faster. Big check mark there. But is it actually smarter at the end of the day? Well, take a look at this. This is a head-to-head showdown after a lot of training. The numbers pretty much speak for themselves. The OlmoHybrid is outperforming its pure transformer cousin in math, STEM, you name it. It's not just more efficient, it's just plain better.
But here, this is where things get really wild. When you test it on tasks with a ton of information, what we call long context tasks, the hybrid model just destroys the competition. I mean, look at that, a more than 14-point jump in performance. That's not a small improvement. That is a gigantic leap forward, showing just how valuable that storyteller part of the brain really is. So when you put it all together, the solid theory, the crazy training efficiency, and the flat-out better performance, it really starts to feel like we're on the verge of a massive shift in how we build these AI systems.
And, the researchers themselves are not shy about it. In their own words, they say their results suggest hybrid models dominate transformers both theoretically and empirically. That is a huge claim, but man, they've got the data to back it up. Which brings us all the way back to that question from the beginning. Could this really be the end of the Transformers' reign? After years of just total, unchallenged dominance, is the king about to be dethroned by a new, more powerful, and way more efficient hybrid architecture? All the signs are starting to point that way.